All right, for this video, I wanted to teach you how to write polynomials using roots. Now, a root of a polynomial is just going to be a number where when you evaluate the function at the number c, you will always get 0. And that's where the function f of x is going to cross the x-axis. So c, we call that a root. We also call that a 0. And we also call that an x-intercept. And today what I wanted to do is I wanted to show you how to take those roots and then from there building up the polynomials. Now we're going to be using this rule over here. If x equals c is a root of the function, then x minus c is going to be a factor of the function. So let's try the first one from the classwork. We need to write a polynomial for the given roots, and we're given x equals 4 and we're given x equals 2. So 4 and 2 are where the function is going to cross the x-axis. Those are the roots. What we want to do is we want to take those roots and make them into factors. So what we're going to do is we're going to subtract the roots from x. So that means x minus 4 is going to be a factor, and x minus 2 is also going to be a factor. So what we're doing is we're taking the numbers as they are, and we're putting them as being subtracted from x. And it's always going to be a subtraction symbol on the inside. Now what we can do is we can use the FOIL method to multiply these two factors together. So FOIL stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So the first thing we're going to do is we're going to multiply the first two terms, the x and the x. And when we do that, we get x squared. The next thing we're going to do is we're going to multiply the outer two terms, the x and the negative 2. And that's going to give us negative 2x. After that, we're going to multiply the two inner terms, which are going to be the two terms on the inside, the negative 4 and the x. We multiply those to get negative 4x. And then the last two terms we're going to multiply are the last two terms inside the parentheses, the negative 4 and the negative 2. And negative 4 times negative 2 is going to give us positive 8. All right, so now the last thing we do is we combine the inner two terms because they both end in an x, so they are like terms. We put the negative 2x with the negative 4x, and we get x squared minus 6x plus 8. So this is going to be our polynomial. So this polynomial crosses the x-axis at 4 and 2. Positive 4 and positive 2. So with the roots, we can create the polynomial. The second one we're going to do is going to be just like that. We're going to be doing number 2 on the classwork. And for number 2, our roots are going to be negative 3 and negative 6. So what we're going to do is we're going to take these two numbers and subtract them from x. So we get x minus negative 3, and we get x minus negative 6. Notice that whatever number we have, whatever numbers that were given, we always use a subtraction sign in the middle, no matter what. And what that's going to do is it's going to interact with the negative number that we already have, so a double negative is going to become a positive. So we can write this as x plus 3 and x plus 6. And now we use the FOIL method to multiply these two factors together. X times x gives us x squared. X times 6 is going to give us 6x. The inner two terms are 3 and x. We get 3 times x. And then the last two terms are the two numbers at the end, the 3 and the 6 multiplied to give you 18. The middle two terms are going to add up to give you 6x plus 3x, which is going to be 9x. And we bring down the x squared and the positive 18 at the two ends. And we're done. All right, let's try one more like that. We're going to be doing number 5. X equals 8 and x equals 0. So what we're going to do with these two roots is we're going to subtract them from x. So we're always subtracting from x. We get x minus 8 and x minus 0. Now the x minus 8 is going to stay the way it is. We can't change that one. But the x minus 0 is just going to give us an x. So if we're subtracting 0 or adding 0, we can safely ignore the 0 for now. Now we have x times x minus 8. When we multiply both terms in here by an x, we get x times x, which is going to give us x squared. And we have x times negative 8, which is going to give us negative 8x. And we're done. That is our polynomial. Notice that it has a greatest common factor of x, so that when we factor, we can take that x out. All right, let's try some with fractions. Number 6 gives us a chance to try a fraction out. We're given x equals 2 and x equals 1/5. Now, I'm going to subtract both of these numbers from x, like we've normally been doing. So I get x minus 2 and x minus 1/5. The x minus 2 is going to stay the same. There's nothing I can do with that. Over here, with a fraction, we're going to take the denominator and slide it in front of the x. So we're going to be taking this 5 in the bottom and sliding it under the x so it appears on the other side. And what that's going to do is it's going to put the 5 before the x. And then now that the 5 is gone in front of the x, I'm left with a minus 1. And now I can do the FOIL method using these two factors. So when we ever get a fraction, we need to slide the denominator in front of the x. So doing the FOIL method, I get 5x times x, that's 5x squared. The outer two terms are going to give me negative 1x. The inner two terms are going to give me negative 10x. Negative 2 times 5. And negative 2 times negative 1 is going to give me a positive 2. So now the FOIL process is done. All I have to do now is combine the two middle terms, which are the like terms. I get 5x squared. Negative 1 minus 10 is negative 11x. And then I bring down the plus 2, and I'm done. That is my polynomial with the roots 2 and 1/5. Okay. The last example we're going to do is going to be an example with an imaginary number. For number 10, we're given x equals 2 plus I and x equals 2 minus I. Now, what we need to understand before we do this is that both of these are imaginary numbers, and they are conjugates of each other because one has a plus and the other has a minus. But the way we're going to attack these is the same. We're going to be subtracting these numbers from x. So I subtract 2 plus I in the first factor, and in the second factor, I'm subtracting 2 minus I. Now what this is going to do is this is going to put the x with the 2. So I'm going to start off by grouping the x with the -2. The x with the -2. And then this I on the inside is going to have this negative distributed to it, which is going to make it a -I. Over here in this factor, I'm again going to put the 2 with the x, so I'm going to get x minus 2, but then the negative and the negative make a double negative, which is a positive I. So now I can do the FOIL method. I'm going to multiply the first two terms, which I'm going to put in yellow. I'll underline the first two terms, x minus 2 and x minus 2. That's going to give me x minus 2 squared. Since I'm multiplying x minus 2 by x minus 2, I'm going to change my color to red to get the outer two terms, x minus 2 and I. That's going to give me plus I times x minus 2. Change up to blue to get the inner two terms, the -I and the x minus 2. That gives me -I x minus 2. And then the last two terms I'm going to put in green. That would be the -I and the positive I, which multiply to give me -I squared. So this is going to stay unchanged. I'm just going to bring that down the way it is. The interesting thing to note about the two middle terms is that they're always going to be canceled out. Because I have a positive I and a negative I, those are going to add up to give me 0. So I can safely cancel those. And then the end term, the -I squared, is going to give me minus -1. And that's because of the rule I squared is equal to -1. So I get a minus -1. Now the good thing about that is I have a double negative at the end. So that's just going to give me a positive 1. And over here, I still have x minus 2 squared. Okay, so now I just need to figure out what x minus 2 squared is, and I'll have it. Notice that I'm squaring x minus 2. So that means I'm multiplying it by itself and adding 1 at the very end. And now I FOIL these two. When I do that, I get x squared minus 2x plus 4, and then at the very end, I add a 1. When I combine the two middle terms, I get -4x, so I get x squared minus 4x, and then 4 plus 1 are going to combine at the end to give me plus 5, and I'm done. There's nothing more I can do. So if you have two imaginary roots, you can still subtract them from x. You can still figure out what the polynomial is. It is a longer process, but that is what you have to go through when you're given imaginary roots. And I hope that helps.